to anyone in the room, and you could get the results from them if you want. Which one would you prefer? Okay, so just open the lab up for me then, and I'll get it going. I'll put it in there for you. It's up to you. If you want to work with them today at the start, they can give you the information. Okay. Okay. Dun, dun. Dun, dun. All right. So here's what we are going to do, ladies and gentlemen. Today, what we're going to do is I'm going to give you some time to finish the lab from yesterday. There are 4 questions that you have to do. Now, I am going to go over a few things that will basically answer those 4 questions for you, and then I will give you some time to do those 4 questions. When you finish those 4 questions, you will turn in your lab. When you turn in your lab, I will then give you some time to work on the problems that we showed you the other day, the ones that you could do out of the packet. At the end of the hour, I'm going to go through 3 more formulas that we are going to learn. Here, 2 more formulas that you are going to learn. I have added some notes to the board. Okay? I've added notes about the fact that temperatures must be in Kelvin. I added a note that in PV equals nRT, this must be in liters. And then I added a note about a couple formulas that I'm going to give you today. Those notes will not be on your test. Okay? So those extra things will not be on your test. You need to make sure that you either know them or you write them down. Now, I've been stressing to you about temperature being in Kelvin since we started this unit, or when we do gas laws. So that you should know. Also, ladies and gentlemen, you are going to need this conversion on your test. I will not give it to you. So if you're going from milliliters to liters, you should know how to do that by now. But if you don't, there is the relationship for you. Okay? So, again, your lab should be open. You should be ready to go. We should be able to get some things done here. As long as we're doing things. Okay. So, in the lab yesterday, we found the mass of the magnesium ribbon. Again, you can edit this formula if you want by clicking in here. You can do a separate formula underneath if you want. But you need to show me the formula that you are going to use to get from mass to moles. You have to show me that. Now, ladies and gentlemen, that is unit 5, and that is right here, going from mass into moles. So, you need to show me that formula, what would be on top, what would be on the bottom, and then you need to do your answer. You then need to give me a second answer. Okay? Yes.
Do you want that in sig figs?
Should always be in sig figs, yes.
What if it's 0, 0, 0?
Remember, zeros at the start don't count. So if your number begins 0.00, you have not gotten to a sig fig yet. The first non-zero digit, so 0.007, the 7 starts your sig figs. Whether the zeros are before or after the decimals, zeros at the beginning of a number are never significant. So in reality, your mass, which was something like 0.043, 0.044, that only has 2 sig figs. So therefore, your answer can only have 2 sig figs. Okay? In number 2, ladies and gentlemen, pay close attention here. I'm helping you out with your questions. When we collect a gas through water. One of the things that happens is some of the water evaporates, vaporizes, however you want to describe it. Meaning some of the water turns into a gas. So the gas that we collected in the top of the tube, when it was like this, ladies and gentlemen, that gas was not just the hydrogen gas. It was also some water vapor. Not a lot, but some. So this question is asking you to calculate just the pressure of the hydrogen gas. For our total pressure, we are using what was the room pressure yesterday. You have that number collected in your data table, the room air pressure. Okay? Now, how did we create the room air pressure inside this tube when it was like this? What did we do that made this equal to the room air pressure? We put it in here. We put it in the graduated cylinder. Now, my volume right now on here, and I just have some water in here, ladies and gentlemen, just to be able to show you. My volume right now is about 55 milliliters. If I put this all the way to the bottom of my container and I look at my volume, it has changed to 52 milliliters. It has gone what? From 55 to 52. It has gone down. Now, have I changed the temperature inside there? By putting it in there, have I changed the temperature? Think about this. Come on. Have I changed the temperature inside for that gas? No. Have I changed the amount of gas inside there? No. What causes the volume to change? Pressure. First law we studied, Boyle's law. What that means, ladies and gentlemen, is that the pressure inside is changing along with the volume. We have no way of measuring that. So what we did is we did something called equalizing the pressure. We want the pressure inside this tube to be equal to the pressure in the air in the room. That way we can measure it. The way we did that is we adjusted this until the water level in this graduated cylinder and the water level inside this tube were at the same level. Now what I know is the air pushing down on here and the air pushing down in there is at the same pressure because the waters are at the same level. That was my way of measuring the pressure inside this tube. Okay? So we did the volume when these two waters were equal. Now, what that also means, ladies and gentlemen, is that pressure that I just got equal to the pressure in the room is now the total pressure in there. But besides hydrogen gas in there, there is also water vapor. There is pressure from the water vapor that became a gas when the gas bubbled through all of the water. Now, the nice part about that gas, that water that is in there is a predictable way to find it. In other words, we can go to a reference book, we could go to Google, we could go to any reference material that we want and find the vapor pressure of that water. The pressure of the water created by bubbling it through water at that temperature. That is the last page here. Excuse me. I got this offline. It is a copy of a page out of this handbook. The pre-Google handbook. The handbook that I had to look things up in when I was going through school. this has all kinds of known values. Well, the vapor pressure of water at a certain temperature is a known value. You can look it up. But it is based on what? What did we use to decide which of these values we would use? We used the temperature of the water. So this comes out of a reference book, but we choose our value based on the temperature of the water. So we find the temperature of our water, 19 degrees, 20 degrees, 18 degrees, and we got a value. Now it's small, but we got a value, 2.1978. That value, ladies and gentlemen, is the number that you wrote down in the bottom of your table here. No. This number right here, you should have gotten off of the table on the last page based on the temperature of your water. Questions? Now, when we're doing this calculation, ladies and gentlemen, we have this number and we have this number, meaning you can solve for this one. And this is a simple addition problem. You should be able to rearrange that and solve for this number. Questions? Okay. Question number 3. I have seen people make mistakes on this. Some common mistakes, so let's clear this up. First of all, the formula is PV equals nRT, and you are solving for N. N is going to be a small number, and it should be a number close to what the calculation number 1 values were. Okay? That's what it should be close to. To get this, the pressure that you are going to use here is the pressure of just the hydrogen gas, which means it's the numbers that you collected right here in number 2. That is what you use for pressure. Your volume here is the numbers that came out of your table up above here, but volume must be in what unit in PV equals nRT? This is not in liters. Here's your conversion to get it from milliliters into liters. And then you can put it into PV equals nRT. Now, N is what we are solving for. We need an R value. Yesterday you told me we should use 8.31, and you were absolutely correct. That is the R value you are going to use in this formula because it is the R value for a pressure of kPa, which is what our pressures were measured in this lab. So now, you got this number, you got this number, you got this number. Finally, you need to put temperature in, which is right here in your table, but please remember it must be in Kelvin. Now, if you chose to write these numbers down in Kelvin, I don't care. That is absolutely fine. But if you didn't, when you put them into this formula, they need to be in Kelvin. Now, rearranging this formula to solve for N, you are going to take your pressure and your volume, multiply them together, and divide it by your R value and your T value. That is what you end up doing. And that is how you get the N in calculation number 3. Are there any questions on that? Problem or calculation number 4, you are going to do a percent error. So you are literally going to take the number you got in 3 here, the moles, and subtract the moles from calculation number 1, the moles of magnesium. And you are going to divide it again by the moles of magnesium. The reason for that, ladies and gentlemen, and this is a little bit of a preview of the next unit. In this chemical reaction right here, which is what happened, For every 1 mole of magnesium that we used at the beginning, we should have created 1 mole of hydrogen gas. They are in a 1-to-1 ratio in this reaction. Now, the acid that we used was in excess, meaning you weren't going to run out of it. Your reaction stopped when you ran out of this stuff, which means this determined how much of this you created. Now, the one thing I will warn you about in this calculation is these two numbers need to be subtracted in parentheses and then divided by, again, that same number for calculation number 1. I do not care if your number comes out positive. I do not care if your number comes out negative. What I care about is what percentage it is. A good lab should be an excellent lab should be under 5% air. I don't care if it's plus 4.7% or if it's minus 4.7. That is under 5% air. A well done lab, not excellent, but still well done, would be within 10%. So maybe you're at 6.5% air or at negative 7.1. That is still a well done lab. If you are between 10 and 20%, you did the lab, you probably didn't do something right. Something went wrong for yours. We could talk about sources of air all day. We're not going to. And if you were more than 20%, I would guess you did something wrong in your calculation. This lab normally comes out pretty well. Okay? But I'm not grading you on how well it came out. I'm just grading you on if you do this calculation. Questions? Now, I also just answered all 4 of the questions for your lab after this. I talked about why we equalize the water level inside this gas collecting tube and inside here. It is the only way we can find something. You need to tell me what it is the only way of finding. What gases make up the total pressure of the gases collected inside the tube? What gases are inside there? We just literally talked about this. Question number 3. What is the value for vapor pressure of water in this experiment based on? And question number 4, how was the value for the vapor pressure of water in this experiment found? We just went through that for both of those. So, ladies and gentlemen, here's what we have. You have the next 30 minutes. You have 30 minutes to finish this lab up and get it turned in. Okay? You have 30 minutes, if you finish this lab, to take out your packet and do the problems that you can do. And then after 30 minutes, I'm going to move on. Katie. Okay. I am here. I will come over and I will give you as much guidance as I can. But again, just answered all 4 of those questions. Again, I'm not asking you to do this alone. Get with your lab partners, discuss these things, write your own individual answer based on the discussion you have with them. 30 minutes is on the clock, ladies and gentlemen. Go to work. I'll be there in just 1 second, Katie. Yes. So your result, yes, you just copied down the exact same. That's a great question. Actually, that was hey, nobody said trial 1 and trial 2 had to give you different answers. It is quite possible that if your water temperature didn't change, calculation number 2, you'll get the same answer. Show me the same answer that you got above if you got the same answer. I'm fine with that. If your numbers didn't change, you don't have to try to make up a different answer. Okay? Go to work. So you can get the numbers from them, you can get the observations from them, and then you guys can work on the questions and things. You ask me a question, the worst thing I can tell you is you should know that or don't be normal. If you think you have a problem with your calculation, I'll be happy to work on it. Is providing this number with this first, one, this. Part of this. So good. That's what I'm right out. These two, we're on the yes. Well, I do this time this time. I would do this minus this divided by this and then I would multiply it up here and here. You can do that with the numbers because it's not going to get the right answer. The first two numbers need to be in parentheses. Okay? Now your two numbers are really close together, right? You're expecting a very low percentage. Why would you change something that shows? That's my fault. If you're telling me you rounded it wrong, you should correct that. Right? Why don't you change your answer? Yes. How much? I don't know. But it is going to change your answer. Yes, tonight. Oh, okay. Sorry. Normally when I said walking away, you're saying wait. Okay. Yeah. So, you know, the good is that you don't have the second try. But with this lab, because we're going to solve a little mistake.
The one is serious. What do you think?
Yes.
I see why.
This lab is due today, ladies and gentlemen. So before the end of the day today, midnight, starts tomorrow, starts D17. Make sure this is turned in. Yes.
Why? Mine is at 696.912. You don't around.
Go back to the invitation. This -3 means you're going to select that this replaces the D.
So I'm gonna get
So you're going to put 2 zeros in front of that 1. 0, 0, 0, 1, whatever the rest of it is. No, you didn't. 0, 0, 0. If that makes sense, put 2 zeros in front of that. Those zeros are after the decimal. Now, 1, whatever you're doing. Okay.
you need just you need to try to. Maybe like you know. Please, three. What did you say?
Use PR.
No, it's one.
You should always put your hands up each the same things pressure,
Oh, that one? Yeah, I'm thinking right now. Make it. What? Number 4 shots. Number 4 shots. Girl, I'm still in 3. Oh, I don't know.
These are the numbers in the packet when you go back to doing the packet that you can do, ladies and gentlemen. For sure that you can do. Renee, you do it exactly the way I have it shown for you. Parenthesis, number for calculation 3, minus number for calculation 1, close the parenthesis, divided by number for calculation 1. Okay? you have 54%? Did you do your second one? What did you do in your first one? Okay, so you had one that was 0%, one that was 54. You did one well, one sucked.
Wait, did I have how much percent? How much percent did I have?
Always give your results from one.
Lord.
You can just show me the answer. Yep.
So you do it. Something like that.
What's your number? Doing your math right. Yes. Yeah. Think about this. We collect 5. Into reality. It started with a small number. We should do
What? Did you get 3? You might be right. That one for the bottom, this is one, yeah, that one. That's the pressure. Come on, Greg. Oh my gosh. Yeah. Um,
I'm sorry? Are you asking me a question or are you just letting me know? Okay. We should figure it out, so that's it.
Wait, let me see.
Now let me see.
Okay. Yeah. I was What is it? The first. Oh, okay. Wait, you said that. Yeah, but, wait, no. Yeah, but I got zero. I actually got zero. You got zero? What was your value?
Holy, there's all, one of them can't be played for. Okay. You never multiply times the temperature. You need to use that clock. The temperature in there, over that. Okay. What number is that, Claire? 12. Okay, all set for you, Claire. Thank you. Yes. What? What's the question? I'll read. Yeah, I'm sorry. What was your valve? Take out the outside. Where did you find the vapor pressure water? go to your data table and point out the vapor pressure water. I don't know which one you're pointing to. Which one are you pointing to? I can't see your cursor. So that's the vapor pressure water, right? So how did you get that number? Where did you find that number? That's what that question's asking. You got that number. You wrote it down. You had to get it from someone. Okay, you should. You should. Ask your team. Where did you get your number from?
I don't know. Just find your.
No, you didn't. You used that number to finalize. That number you were able to find.
Oh, and
Where did you get that last number from? One question is asking you where did you get that number, the other is asking you how did you pick that particular number?
if we didn't. Oh.
So in that formula,
Oh yeah, it's always. Second one is. Gonna get the exact same.
Okay, ladies and gentlemen, you got just under 6 minutes left if you have questions for me. Yes. So, three was asking you, how did you get the number that you just told me? Question number 4 is asking me, where did you get that? Oh, read it. Read it. On there is the answer to that question, very easily. Yes. The same number. What do you think? You're upgraded by anything as well. Why is that not perfect? Well, you should be. That's one of the first things you learn in this class. Any number by itself is zero. So zero's meaningless left. 0% is You asking me or someone else? For what? Did you read the purpose? Whose law? Ideal. It's called ideal, not ideals. It's not a person. It's the concept. An ideal gas is a gas that behaves exactly as we would like it to. Okay. So we use this one. We use ideal gas law. Hey, ladies and gentlemen, headphones off. Take a look at the problem I have on the board. Now, the reason I have this problem on the board is because some people asked me about this in the answer key. Up at the top is how I would have probably worked the problem, how you probably worked the problem. What volume will 2.64 grams of hydrogen gas occupy at 70.0 degrees Celsius and 725 millimeters of mercury? You've got grams of a substance, you can easily get that 2 moles. So that's an N value. You've got a temperature and you've got a pressure. You are solving for V. Easily done in PV equals nRT. Pressure in, V is what we're solving for. Over here, I took 2.64 grams of hydrogen gas. By the way, be careful of the formula, H2, times 1 mole of hydrogen gas over 2.016, the formula mass for H2, and I got 1.31 moles. Put that in here for N. 62.4 is my R value because of the millimeters of mercury. 343 is the temperature in Kelvin. Solve that, ladies and gentlemen, you get 38.7 liters. In the answer key, I chose to work it a different way. In the answer key, I began with 2.64 grams of hydrogen gas. I converted it into moles, and then I took it into liters. But I used 22.4 liters per 1 mole. Well, the only time the volume is 22.4 liters equal to 1 mole is under what conditions? So now I instead used combined gas laws. Standard pressure, 760 mmHg. Standard temperature, 273. And the volume that I calculated at those conditions equal to my new pressure and my new temperature. Solving for V. In the end, ladies and gentlemen, I get exactly the same answer. Meaning, you can solve these problems in multiple ways. Questions? Okay. All right. Morgan, have you guys ever seen these before? Anyone know what this is? It's a can of compressed air. They use it to clean keyboards. Just hold on to it for a second. Feel it. Pass it along. Okay? Now, I'm going to take and I'm going to clean my keyboard with it. Not to everybody in the room. I don't have time for that. Give me that. Now think about it. There is air inside here. Think about what I'm changing as I'm doing this. No, pass it along. Tell me what happened. How did it change? It got cold. This can is now incredibly cold. So let's take a look at what happened here, ladies and gentlemen, and see if we can't figure it out. So here's my question to you. All right. What happened ultimately in the end to the can? Morgan. What? Temperature decreased. In the end, ladies and gentlemen, the end result is that temperature went down. Now let's go and let's look at the 4 things that could have caused temperature to decrease. Okay? I now know what this one is doing. This one here had to go down. That's what happened. The question is why? Now, as I am spraying the can, what am I changing? And what am I not changing? So in terms of P, V, and N, someone tell me something that changed or something that did not change. Volume doesn't change. This can is no different in size now than it was originally, correct? So could volume have caused the temperature to go down? No. Volume is off the board, ladies and gentlemen. Volume could not have caused this change because volume did not change. Next thing. What about P and N? What am I changing when I squeeze this? The amount of gas, and it's going how? Amount of gas is going down. Now, I want you to think about this for a minute. Here's T and here's N in our formula. I am doing what to T and N? Multiplying them. If I am multiplying my variables, what kind of relationship are they in? Inverse. Meaning, if N goes down, what should that cause T to then do? So is it possible that by letting the gas out of there, temperature went down? No. So now our only hope is pressure. Okay. Now think about this. As I get rid of gas inside this can, what happens to the pressure of the remaining gas inside this can? It increases. Really? Really? Well, let's think about this. We know the amount of gas is going down. Absolutely no doubt, correct? N is down here in our formula. Where is P? Above it. What kind of a relationship does that make for these two? What? Direct. which means if N is going down, so is P. P has to be going down. Does anyone have any questions on what we've talked about so far? Okay, so now, what would that cause T to do if P goes down? They're in a direct relationship. P and T, Gay-Lussac's law, direct relationship. Why did the can get cold? Because of pressure decreasing. Because of pressure decreasing. That is the only possible explanation. This, ladies and gentlemen, is not about solving a problem. This is about understanding a relationship. I expect you to understand relationships on your test. I expect you to be able to tell me what kind of relationship is between two variables, what's held constant. And this is about reasoning through things, kind of like you were supposed to do on the implosion lab that we did in class. We'll talk about that tomorrow. We will also give you another demonstration like this tomorrow. But please understand, why can't it be the amount of gas that caused temperature to decrease? Because I know I changed the amount of gas in there. Why can't it be the amount of gas that caused temperature to decrease? Because the amount of gas is trying to get that temperature to increase. The only change that amount of gas can do to temperature on its own is to increase it. That can did not get hotter. That cannot be what caused this change. This is the change that we know happened. Okay? That is the change that we know happened. It had to be caused by this over here. Questions? Okay. All right. So, here's where we're at, ladies and gentlemen. I am in the EISN, and I am on slide 58. So please open it up to slide 58. Okay. I will not make you memorize whose law this is. The only four that I expect you to know: Boyle's, Charles, Gay-Lussac's, Avogadro's. Those are the four that I expect you to know whose law is who. This law is called Graham's law. Don't expect you to memorize that. Okay? Graham's law says two gases under the same set of conditions, meaning they're at the same volume, they're at the same temperature, they're at the same pressure, and they're the same number of moles, have the same kinetic energy. Why do they have the same kinetic energy? Because they're at the same temperature. Temperature is kinetic energy. Right? Have the same kinetic energy. And therefore, the square root of their masses is inversely proportional to their velocities. Holy crap, that's a lot of stuff. But let's think about this. Two gases at the same temperature have to have the same kinetic energy, correct? Yes? What doesn't have to be the same about those two gases? What is not the same about the nitrogen gas and the oxygen gas in the air that we are breathing right now? They are at the same temperature. They are at the same kinetic energy. What? Don't say wait. What? The mass and the amount of gas. I don't care about the amount of gas right now. But their masses are not the same, are they? So think about this in terms of kinetic energy. If your masses are not the same, what else is not the same? Kinetic energy depends on mass and velocity. Two objects run a race. I run a race against Morgan. We finish tied, meaning we had the same kinetic energy. Let me rephrase that. We don't finish tied. We finish with the same kinetic energy. Who wins the race, Morgan or me? Now, I hope you recognize what the biggest difference between Morgan and I is in terms of kinetic energy, but somebody please state it nicely. For who? Me? Less mass, more mass. Finish the race with the same kinetic energy. Who wins? Okay, but if I have more mass and more velocity, what is that going to mean for my kinetic energy compared to Morgan's? It's going to be more. Who wins? She does. Lighter moving objects at the same temperature are moving faster than heavier moving objects. The way she makes up kinetic energy on me because I have more mass than her, she has to move faster. So any two gases that are at the same temperature, which one is moving faster? What? Don't say that. Thank you. The smaller mass or the lighter one. So in the air is nitrogen and oxygen. Which one is moving faster? Nitrogen, it has a lighter mass than oxygen. Okay? That's the idea behind what we are saying here. So, I'm not going to make you memorize these formulas, but I'm showing you how I am about to get this right here. Kinetic energy of me and kinetic energy of Morgan are equal. Kinetic energy is 1/2 the mass times the velocity squared. Okay? That is the formula for kinetic energy. Again, I'm not expecting you to know that. A represents one of us, B represents the other. So in these formulas, when I have A and total and B and A and B, when I have 1 and 1, 2 and 2, all that means is that the things with the same numbers go together, or the same letters. So here I'm using letters. Here in gas laws, they chose to use 1 and 1, 2 and 2. Okay? So, her mass and my mass are different. Her velocity and my velocity are different. So, first thing I would do with this equation is I would get rid of the 1/2. Why do the same thing to both sides? So I cross out the 1/2. So the mass of A times the velocity squared of A is equal to the mass of B times the velocity squared of B. Now what I want to do is I want to get like terms on one side. I want my masses on one side. I want my velocities on the other. Fair enough? So I'm going to take and I'm going to divide mass of B from this side. What I do to one side, I'm going to do to the other. And I'm going to divide velocity of A on this side and do it to the other. We end up with the mass of B, I flipped it around, over the mass of A is equal to the velocity of A over the velocity of B. What? I'm showing you how we're getting this formula. We're going to put it in a formula like that. But this is still what? Squared. So, we need to take the square root of both sides, top and bottom. So the square root of the mass of B over the square root of the mass of A is proportional to the velocity of A over the velocity of B. Okay, you got that little bank where you have units, ladies and gentlemen? You got that little bank on your periodic table where you have units? Units for velocity, ladies and gentlemen. Meters per second. That is a unit for velocity. Meters per second. What's a unit for mass? Grams. A second ago, we were comparing the velocity of oxygen in the air and nitrogen in the air, correct? I wasn't worried about the percentages of them. I know there's more nitrogen than oxygen. We were just worried about the mass and the velocity of them, right? And we said the mass of the oxygen was what? compared to nitrogen? How do we know? What did we use? What? Formula masses are based on 1 mole of a substance, right? Guess what? In this formula for masses, you can use formula masses. We can assume 1 mole of each. Because it doesn't matter how much is there. What matters is how fast it's moving. So if we know what gas A is and gas B is, we can solve it using formula masses. The same way we said oxygen is moving slower in the air than nitrogen because we based it off of formula masses. So really for this problem here, ladies and gentlemen, you need to know what the 2 gases are and you need 1 velocity. How will you recognize a velocity? What did I just tell you? Meters per second. So, if you have any problem with meters per second, what is the only formula out of everything here that we can use? This one. It is the only formula that involves velocities. Find the velocity of hydrogen sulfide gas that is under the same conditions as carbon tetrachloride gas, which has a velocity of 1.45 meters per second. Now, the one thing you need to be careful of, B here, the velocity is on the bottom here. A here goes with the mass on the bottom here. They are flipped over. Okay? So, we can assume and use 1 mole. This is our formula. Hydrogen sulfide gas has a formula mass of 34.08. 2 hydrogens, 1.08, plus sulfur, 32.06, 34.08. Carbon tetrachloride, 1 carbon, 12.011, 4 chlorines, 35.45, formula mass 153.81. I don't care which one of those you call A and B. The reason I chose this one for gas A is because it's the velocity that I'm looking for. It is the velocity I'm looking for. So what that means is I'm going to end up with VA on top here. Now, I still got to do what to solve this? Cross multiply again. So it really doesn't matter how you set it up. But the most important thing is, if this is the velocity of A, this needs to be the mass of A. I chose gas A to be hydrogen sulfide. Here's gas B. By the way, in your calculator, ladies and gentlemen, learn how to put a number in as a square root. Because this is just one number, you should be able to hit the square root button and type in that number. We're going to do cross products are equal. And then we're going to divide by the number that was times the VA. That is the square root of 34.08. Punch this into your calculator. You get a velocity, ladies and gentlemen, of 3.08 meters per second. Questions? By the end of the day today, if you want credit for your lab that you can earn an A or a B on, your lab report needs to be turned in to me. If you do not turn it in today before midnight tonight, or midnight tomorrow morning, you will not get full credit for it.
Burgers in the morning.
Well, yeah, I kind of like it.
What you say?
I kind of liked when we did it because I had plenty of
You did? It's too early to cook.
Well,
You don't eat breakfast in the morning?
I don't cook it. I mean, I don't make a whole gourmet meal. I gotta cook a whole burger.
Oh my God, you're cooking a whole burger
In the morning.
In the morning. That's terrible. Who would make you do such things?
Cooking class.
Yeah, that's why you took it. To learn how to cook.
I know how to cook.
Then why'd you take cooking class?
So pull up my schedule.
Thank you. Did you just throw away a can?
Oh,
What are you
yeah, I'm
throwing
sorry.
away cans for?
I'm sorry. I actually threw it out.
I'll take your can and I'll take that. Thank you. Thank you. I don't want the bottle. Throw it away.
Ow. Oh my god, you're drinking another bubbler?
3 of them this morning.
Wow.
I was thirsty.
Save some for me.
You were not drinking it. Why would I save some for you?
Oh, you're right. I had to wait till summer. He lost yesterday.
What's that?
He lost yesterday.
Is that the first time this year?
Yes.
Who'd you play?
Probably.
You lost Scrabble. Nobody loses Scrabble.
Well,
What
okay,
the
it was
hell?
very windy and.
Oh, and it was only windy on your side of the
No,
field.
no, listen.
I'm listening.
First half, we were going with the wind.
With the wind.
So.
So they were running against the wind. They were Bob Seger.
Yes.
Okay.
So one of them took a shot and it was going straight into Jemiah's hands, but then the wind kind of made it slow down, so then it kind of like shifted.
Wouldn't that make it easier to catch if the wind made it slow down?
Well, like no, it was like in the air, and like I don't know, it was like in slow motion. Like I don't know how to explain it, but it was like
Okay.
fast at the same time. So then it just went over Jemiah, and yeah, and then the second goal was a breakaway. The second goal was an actual goal. The first one was kind of left because of Jemiah would have caught that unindated from the wind. And then the second one was a breakaway. So.
Okay. I got it. I got it. So you lost to a team you should have never lost to. Okay, I got it.
We should have tied them.
Hello.
Hi, can I come in here?
Sure. What do you need?
The lab. Is it? Because you guys did a lab yesterday, right?
Yep. Come on in. Come on in. Okay. First question. Who's your home base teacher? Mr. Jimenez. Okay. You need to open up your lab then so I can put the alternate assignment in for you. Okay, Adriana?
Oh my god, little girl. I mean, big girl. Why are you using it?
I thought we had enough.
Well, you don't even compliment me.
Wait a minute. What do you mean there's no announcements today? What do you mean there's no announcements today? Why?
Testing? Somebody testing?
Oh, that's right. They're doing bells, but no announcements.
Could you charge my phone? And those are like dead, so I'll just get my regular charger.
Well, see that? Así que viniste sin sudadera ni chamarra ni nada. Then why you complain?
Alright.
Why you say
Yes, my room is colder than outside.
no, actually, it's always colder.
Why you lie?
Oh, nah. The AC. It's not even on, is it?
What?
The AC in the school?
Yeah,
It is
it's
on?
called leave a window open.
You don't have any windows.
Okay, then I can't do it.
Shouldn't you have windows because you're like a chemistry teacher, like a science?
You would think.
That makes no sense. How do you have 3 doors but no windows? What do we?
Because I'm not on an outside wall, so I can't have windows.
You should have asked for an outside.
It was.
They made the chemistry rooms the interior ones. There's nothing I can do about that.
That's so stupid.
I agree with you, but the person who designed this apparently has never been in a chemistry room before.
I just learned that day actually.
Probably the same guy who decided to put rooms that use water on the second floor of a building instead of the first floor.
Exactly.
So that way, if there's any ever overfilling of water, it goes down to the first floor.
Right.
So,
You're so right. Skyscraper that had water.
well, one day I came in and Mr. Arts' safety shower got turned on over Easter weekend. His room was flooded, which was bad, but the computer lab down below was also flooded.
Oh
That was
Which is
worse.
worse. Hi, Mr. Brand.
Hello, Lola. What are you doing here?
Chemistry.
You got ice?
Okay. Good morning, ladies and gentlemen. There are no announcements today, so we don't have to listen to those people try to kill those announcements, which is good. So I get to read them to you because there's testing going on today, ladies and gentlemen. So, all right.
There's no way
You're not nice, but I have Lola.
Es que nos cantamos like the first.
I know, but I'm letting you know that she actually made it to my room because sometimes she goes wandering around the building.
That is not true, Mr. Brand.
She is. She is. She's one of the traveling Wilburys. Okay. Thank you. Bye.
It was all the East Boys.
All right. Attention, seniors. That's you. If you are a senior in good standing and want to make a lasting impression, please considering auditioning for the class of 25 commencement speech at graduation. Your class motto is the best way to predict your future is to create it. Auditions will be held after school on Tuesday, April 22nd in room 320. Please see Miss Imlay for information and to sign up. Boys track had a meet last night. Attention all current physics students and AP physics students and Six Flags Great American Field Trip forms and monies are due to Miss Schunard by Friday, May 9th. See her in room 213 if you have any questions.
When is the date?
May 9th. SASS will be having mental health fair on Thursday, April 17th. That is tomorrow. During first and second lunches in the small gym, come meet community providers and walk away with make and take goodies. You also have a chance to enter 2 win door prizes. College visits this week. Cafe visit today is the Navy, and Thursday, April 17th, is the Army. UW Whitewater is here tomorrow at 1:30 in the Career Center. Attention book club members and curious minds, join us during lunch for your April book club gathering. Whether you've read every book, every word of the book, or just want to hear about the story, everybody's welcome to the table. Bring your lunch and your thoughts and join us. Environmental Science Club. Please join the Environmental Science Club on Saturday, April 19th for the Earth Day cleanup. We will be meeting near the baseball diamond at 10 a.m. Please wear outdoor shoes while we will be cleaning up the East River shoreline and our campus. Students, staff, and families are welcome to join us. Draft Day savings and deals that score only at the Devil's Den School Store on Monday and Tuesday of next week. Remember, after school tutoring is available on Tuesday, Wednesday, and Thursday, 3:15 to 3:45 in room 309. Core and elective class teachers will be there to help you. If you don't want help but a quiet place to work, please come and join us. Word of the day, who cares? Have a great learning day and a happy National Orchid Day. Your lunch today is hamburger patty with chips.
What's the word of the day? Why just give it?
Because I don't want to talk about it.
Was it emotional?
Can we do
Yes. No, I have people here who need to get some help.
Can I do Wordle?
Sure, open up your computer, do Wordle.
It's black.
Nah. You did. You did too.
Wait, can I do it?
All right.
Nothing. He hating on you. What the heck?
He's afraid of your downfall.
Probably because you're white.
I'm the one that's gonna get it right. So like,
Dang, you're right. He asked first.
No, real power.
No, it's because Mr. Brand doesn't want to get canceled.
For real.
True Mexicans first.
Doesn't want to get
Minorities
what?
Look, he's all red.
Why did he
Why
laugh?
you getting red?
He wants to laugh.
I have no idea what you're talking
He's
about.
not a racist, guys. Hashtag he's an ally. Do you hate us, Mr. Brand?
He does.
Wait, are you gonna come to our senior night?
Yes, please.
Senior night.
We'll take a picture with you.
Please. It would actually make our life.
For real. It would make our life.
You know when you say you make my days, make my
For
weeks.
real. Make our life.
We will see what we see when we see what we
April
saw.
29th At 6:30.
April?
April.
Oh, heck no.
Please.
I'm not going to an outside sporting event in Wisconsin in April.
It'll be.
I did my
It's
time
gonna
go
be
and watch
nice,
my
yeah,
kids
I
play.
promise you.
It's gonna be 70 degrees that day.
Yes.
If it's 70 degrees, you have a shot.
So he's fake. You know what? I was gonna announce you in the speech for graduation, but never mind. I was gonna shout you
Get out
out.
of my seat. Get out of my seat.
What?
I gotta put an assignment in for
Game
Audrey.
like that one game. I'm getting 2 West Shot lean on me, bro.
Alright.
8. Bro, we should not run out.
Shoot.
That was embarrassing.
Hey, you're behind on this. Oh, yeah,
Really?
yeah.
What was the last one?
The last one was supposed to. Well, the one you left off was 1/6/25.
Nos ahorraron 7.
1/6/25.
Yeah.
Nos ahorraron 17.
Oh wait, never mind. 4/14/25.
Porque agarraron 8, ¿no? Y luego ya perdí.
You should do crane when you have the time.
I should do what?
Shut up, Finn. You searched it up. I know you did.
What is
I did.
crazy?
That's the word I always start with.
You searched it up.
I watched a YouTube video.
Just hang on, just hang on, just hang on. All right, Adriana. Hang on.
Against West.
Everybody's going at it. That's my first ball this season.
Hi,
Hello, Emma.
Hey.
Or
I didn't
Ella.
realize we didn't have announcements.
Hey, we don't have announcements today.
Whiskey,
No.
I never
realize how.
Okay, Adriana, I switched it on you. Or for you. 10 minutes.
Oh, yeah, definitely because of French.
You don't think so?
No, because I have I'm pretty sure I have to go to
You could shoot for that, right? Would you like Alright, but who hating on us?
Nadia, where are you supposed to be?
Nowhere.
Okay, because the last time I had to send a special email to Miss Matthew that you were with me during this hour
That was because
so that you could play in the game. So if you,
So you took time out of your day to respond to it.
Aww.
of course I
So you
did.
love us. You
No,
love
it's
us.
because we had like a media club meeting, but we didn't know we had it. And